Hi everyone, my name is Renato Barghiere. It's really cool to be here and meet all of you. And we've been talking about CliMA along the week, and today I'm going to talk more specifically about CliMA-Land. You know, this list of authors here, most of them are in the CliMA-Land team, but of course we use lots of packages developed from other parts of CliMA, so CliMA team here. And a shout out for the CliMA folks in the room, there are a bunch here. So I know we're familiar with CliMA now, but what is CliMA, right? So CliMA is building a newer system model whose components learn from observation and simulated data. So what we're trying to do with CliMA is create a newer system model in a new language from scratch. And the idea is that these climate models, they're system models, they have all these compartments and representations of the Earth system. And we're going to use the wealth of Earth observations to drive and determine some parameters of these models with machine learning in mind as well. And more specifically, I'm going to talk about the land model. So why does the land matter? So in this figure here, I show the CO2 flux. Everything that is positive, it's anthropogenic emissions. Everything is negative is a sink. We can see the light green here is the representation of the land sink. And the land is responsible for almost a third of all the anthropogenic CO2 absorption. But we can see that most of the interannual variability of the CO2 uptake is due to the land. So land uptake varies a lot. So we need to understand a little better why land CO2 uptake varies from year to year. Plus, we live here on land, so another reason for us to understand a little better. So I just want to show this image here from showing the land uptake simulated by 11 Earth system models in the past 3 CMIP exercises. And we can see from pre-industrial times to the end of the century, and we can see that individual members disagree substantially, not only in the sign, but also the magnitude of the land uptake by the end of the century. And there are many reasons for why these models disagree among themselves, but the IPCC report, and I quote, says that transfer of radiation, water, and heat in the vegetation, soil, atmospheric continuum are treated very simply in these global ecosystem models. And now we live in a very exciting era where we can measure lots of exciting things from space, and we can have here in this animation showing a glimpse into photosynthesis. And one of the ideas of CliMA is actually use all this wealth of data. So here is sun-induced fluorescence. When plants or algae photosynthesize, they fluoresce because of photochemical quenching. And we can measure that fluorescence from space. So we can see nicely here photosynthesis increasing in the summer in the northern hemisphere, and then increasing in the summer in the southern hemisphere. And now, one of the innovations of the land model is that we can have these flux towers from the skies. So flux towers are these towers that are installed in forests and vegetation around the world. We probably have like 300 of them. And they measure fluxes of radiation, water, heat, momentum from the surface to the atmosphere, but they are very localized. So the idea of using the same type of metrics but from space means that we can cover the whole planet. And so some of the new capabilities and paradigm shifts in CliMA-Land is that our radiative transfer model is hyperspectral instead of 2 bands. We can simulate sun-induced fluorescence. We can have vertical and horizontal canopy heterogeneous structure represented in these models. Actually, I did my PhD here in the UK, and it's good to be back. And I was working with Jules, and part of my PhD was to implement this sort of parametrization scheme of horizontal 3D structure in the radiative transfer model. And we can also calculate spectral properties from biochemical components instead of using a lookup table to prescribe all the parameters of the surface. And you know, why a hyperspectral radiative transfer scheme? Well, I had to show a picture of this dude here since we're in Cambridge. And for a long time, we know that light contains lots of different colors, and different parts of the spectral radiation, short radiative band from 400 to 2400 nanometers indicate lots of different properties of the land. So we can get a lot of information if we go from a 2-spectrum Earth system model to a hyperspectral Earth system model. So we can start thinking about surface processes like that. And I want to talk about one of the models of CliMA-Land, which is highly modular submodels, which will simplify hypothesis testing. So I'm just talking about radiative transfer, but we have people in the room working with snow, the coupler, and we can switch and swap these different things and test different hypotheses so we can get a better understanding of processes in the land and how that impacts the atmospheric circulation. We can also derive parameters from model data fusion. Yesterday we heard about Bayesian techniques, and we use some of that in CliMA-Land, so we move away from the parametric limitation of lookup tables. And then there's the computational efficiency. So Julia can be running GPUs quite easily, so we can simplify uncertainty of quantification and also allow for multiple climate projections by perturbing parameters. Here is just a publication snapshot. So we already have these papers published using CliMA-Land, and I suggest if you're interested, go and look up. But some cool stuff that we do is like showing how the 3D structure affects photosynthesis and water and transpiration fluxes. We have also now our first global simulation of photosynthesis and transpiration, and also sun-induced fluorescence, and we can actually compare that with satellite data. And without any tuning, the model is already pretty good and comparable to other land models that are around for years. And finally, please find us and collaborate. CliMA is open source, it's on GitHub. You can go to github.com/CliMA. And CliMA-Land is sitting in like these 2 repositories, mostly CliMA-LASM and Land. And you can go there, have a look of what we do, collaborate, open an issue, and we're happy to take people on board with us. I'll stop here. Here's my Twitter and my email. If anyone has any questions and want to reach out later on, please feel free. Thanks.